Hey everyone, in this video we are going to begin chapter 6, which is called Rational Numbers and Proportional Reasoning. The set of rational numbers is defined as the set Q. We remember this symbol from earlier in the semester. Q stands for the word quotient, quotient meaning fractions. Right, so the set Q is A over B, so the set of all numbers A over B, where A and B are integers and B is not allowed to be 0. All right, so A and B can be any integer. That means they can be positive, they can be negative. A is allowed to be 0, but B is not. And these numbers can be as big or as small as you can imagine. All right, so you're not going to see decimals. As you can see in this definition, we are excluding decimals, so we're not going to have any fractions where we have decimals over decimals or fractions over fractions. Right, so the set of rational numbers is just defined as the set Q of the quotients, which is the set of all numbers A over B, where A and B are integers and B is not 0. You're going to see the word unit fraction a lot in the Georgia math standards, and a unit fraction, just so you know, is any fraction that has a numerator of 1. All right, so 1 over 2. All right, so just some examples. Let me see if I can use my pen here. So like 1 over 2, 1/2, 1 over 4, 1 over 6. So you're going to see the word or the phrase unit fractions a lot in Georgia's math standards or in the Common Core standards, and that is what a unit fraction refers to. All right, so we're going to look at 3 models for teaching fractions. We're going to look at the bar model, which is also sometimes called the area model. We'll look at the number line model, and then we'll look at the set model. All right, so I have just some little visual representations of each of those. The bar model, this is sometimes called like fraction strips. You can see that let me change my pointer. You can see this long bar at the top represents a 1, right? So an area of 1. They've broken this down into 2 pieces. That means we have 1/2 plus 1/2 is 1. And here they've broken it down into 4 pieces, so that's 1/4, 1/4, 1/4, and 1/4. Number line model is very similar, just instead of using little rectangles, we're just using a number line. And then a set model is where you're actually using objects, like for example, you might have 3 circles and maybe 2 of them are colored in. So we would say like 2 over 3 or 2 out of 3 or 2/3 of the fractions are colored in. Right, so you can also use objects using the set model. Alright, so for the bar model, I'm just going to read to you just a little description of each one. Right, so it says the simplest representation, or maybe the way that you want to initially introduce fractions, is by using the bar model or the area model. This is where the entire bar represents 1, and then the shaded area represents the part. The number line model is also useful for introducing fractions, and it kind of, introduces this concept that every time we've been drawing a number line in the past, there's been these other numbers that are in between 0 and 1. So every time, we've drawn a number line in the past, we put 0 in the middle, and then 1 and 2 and so on, that there are really, let me change my pointer, there are really numbers in between here that we're not writing down. So in between 0 and 1, we would have the number 1/2, or the number 1/4, or the number 1/3. All right, and then as we move past 1, we might have 1 1/2 or 1 1/3. 1 2/3. Right, so on the number line, using the number line model, we can emphasize that each little space in between these numbers also represents a rational number, right? Represents one of our rational numbers. All right, and then area model. This is, or excuse me, our set model. This is one of my favorite ways that I've found so far. All right, so the set model just uses some sort of object. In this case, it would be little cubes. You can see that 2 out of the 8 cubes are red, so we would say 2/8 or 2 out of 8 cubes are red. Equivalent fractions is another topic that you're going to see in the Georgia's math standards, where it's going to have students write write a fraction that is equivalent to a given fraction. Right, so equivalent fractions are numbers that represent the same point on a number line. In the grade 4 Common Core Standards, students should be able to demonstrate and explain why one fraction is equivalent to another fraction. So for example, in the 4th grade, students should be able to tell you why is the fraction 1/2 equivalent to the fraction 2/4. All right, so we're going to do an example. I would say this is like the area model. All right, so it says, in each case, subdivide the figure shown on the right to show the equivalent fraction. All right, so here on the left, we have a box that has been split up into 4 pieces or 4 squares, and it says 1/4 is shaded, so we've got 1 out of the 4 squares shaded, and we're supposed to be representing the fraction 2/8. Right, so the 8 tells us how many squares we should break the fraction, or excuse me, break the box up into. So we're going to start by drawing a line down the middle and then 3 lines horizontal to give us 8 little boxes. And we're going to shade 2 of those boxes. It does not matter which 2 you shade. I just shaded 2 random ones just to show you that it doesn't have to be the bottom 2 or the top 2, or they don't have to be side by side. It does not matter which 2 you shade. That will represent 2/8. Right, so if you wanted to emphasize that these were equivalent, so if you wanted to make it sort of match our picture on the left, you could have shaded these bottom 2. Right, so, and obviously this would go away. All right, so if you wanted to just sort of emphasize, let me switch my pointer again. If you wanted to emphasize that they represented the same amount, you can see our box on the bottom right is shaded. You could shade kind of the same bottom box on the right hand side. Right, now we've got a circle, and we're asked to subdivide the figure on the right to show the equivalent fraction. Our circle on the left is split up into 3 equal pieces, and 1/3 is shaded, so just 1 out of the 3 pieces is shaded. We need to split our circle up into 9 pieces. So you can see I've just drawn a line down the middle and then an X just to split that circle into 9 slices. I'm going to shade 3 of the slices. It does not matter which 3 you shade. 1, 2, 3. All right, so I have shaded 3 slices. You could kind of rotate this in your mind to see that it is equal or equivalent to the fraction or the area that is shaded on the left. If students were, maybe felt like that these did not match up, you could have these, cut out onto strips of, onto pieces of paper, and then have them line that up to show that they matched. All right, so now we're going to write 3 equivalent fractions for 3/9. I found this little graphic online. It's just these fraction strips. So at the top we've got one whole, then we've got it broken into two pieces, so 1/2 pieces of the length 1/2, and then 3 pieces, so that's little pieces of 1/3, then 1/4, 1/5, 6th, then it skips 7th, and we have 8th, 9th, 10th, and then skips 11, and then 12th. Alright, so I liked this concept because I was thinking you could find 3 knots. So here I'm looking at the dark green strip, so that would be 1, 2, 3. So this would be 3 nights. Right, then I'm going to draw a line, and then I can kind of just match up with the other colors and say, okay, well, here's an equivalent fraction. You can see it matches up perfectly right here with 1/3. Right, so 1/3 is an equivalent fraction. If you scoot on down, you can see that 1/9, or excuse me, 2/6. We have on this brown strip here, we have 2 of the 1/6 squares, so that would be 2/6. And even down at the bottom, you can see I've got 4/12 would be an equivalent fraction. But I'm just going to grab 2 from here. I'm going to grab 2/6 and 1/3. And then I'm going to show you an alternative way that you could find an equivalent fraction, because this doesn't always work. So for example, for 2 knots, there's no equivalent fractions for that one that are shown on this on these fraction strips. So this method isn't always going to work. I sort of hand-picked that 3 knots to make this work. Alright, but let's look at a different way for how we can find an equivalent fraction. So if that little, fraction strip method doesn't work, you can try this approach. Alright, so we're going to write 3 equivalent fractions for 3/9. You can do this just by multiplying the top and the bottom by any integer. I'm multiplying by 2 here, so whatever I do at the top, I've got to do to the bottom as well. So that's 6/18. Now I've already got my 2 from before, 2/6 and 1/3, so another equivalent fraction would be 6/18. So there's my 3 fractions. 2/6, 1/3, and 6/18. And there are many, many more equivalent fractions that you could find. You could multiply the top and bottom by -2. You could multiply the top and bottom by -5. So there are just an infinite number of equivalent fractions that you could come up with here. Alright, so on number 3, it says, referring to the figure, represent each of the following quantities as a fraction. Alright, so we've got this drawing here, or this figure. We've got, let's see, 4 dots, so 4 rows, and then 1, 2, 3, 4, 5, 6 columns. So there's 24 dots in total. Alright, so 24 dots in total. And then within our little rectangle, we have 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 dots within the rectangle. We have got, let's see, 3 and 3. So it's 9 dots within the red block here, within the red square. It was supposed to be a circle, but that was the best I could do. So when it says circle, that's what it's referring to. And then you can see they have a little bit of overlap here. This 1 dot is in the overlap of the rectangle and the red circle. Alright, so it says we're supposed to write each of the following quantities as fractions. We're supposed to represent the dots in the interior of the circle as part of all the dots. Alright, so the dots in the interior of the circle, we said there were 9 dots in the interior of the circle, and there were 24 dots total. So that'd be 9/24. Don't worry about simplifying here. And then part B says the dots that are in the interior of the rectangle as part of all of the dots. Right, we counted up the dots that were inside the rectangle. We said there were 8 dots, so that's 8/24. And then part C says we're supposed to represent this as a fraction, the dots in the intersection of the rectangle and the circle as part of all the dots. All right, so the intersection is just that one little dot right there. All right, so the intersection is that one little dot, so there's 1/24. All right, and just to emphasize here, this is the intersection. Okay. All right, now we're going to look at ordering rational numbers. So ordering rational numbers. In the Grade 4 Common Core Standards, it states that students should be able to compare two fractions with different numerators and different denominators and determine which one is larger or smaller. All right, so we're going to compare the fractions 5 and 11 over 12 using bar models or area models. All right, so you can see I've got two little strips here, and I've got the top one broken up into 12 pieces, and I've got the bottom one broken up into 5 pieces because those are my denominators. That's my whole. All right, so if you're thinking of a fraction as a part over a whole, then the denominator represents the whole. All right, so for 4 over 5, we've got that fraction strip split up into 5 pieces, and for 11 over 12, we've got it split up into 12 pieces. All right, so you can see I've shaded 11 out of those 12 pieces. That's 11 over 12. And then here I've shaded 4 pieces for 4 over 5. And since these are the same length, we can use this bar model to figure out which one is larger. So which one is larger? Be 11 over 12, right? So 11 over 12 is larger than 4 over 5. So that's the bigger one. 4 over 5 is the smaller one. All right, so here is a general formula or general set of steps for ordering fractions. Step 1 is to create equivalent fractions that have the same denominator. Step 2 is to order the fractions by the size of the numerator, and then rewrite the fractions in their original form. Right, so you're going to force them to have the same denominator, and then you're going to look at the numerator, and that's going to tell you how to order your fractions, and then you're just going to rewrite them to their original form to get your final answer. All right, so here's our problem. I grabbed this problem out of the textbook, and if I was making this problem up, I would have used better numbers, but I wanted to demonstrate with the numbers they had, just so you could see like the worst case scenario. So it says arrange the fractions in decreasing order. We've got to figure out which one's the biggest and which one's the smallest. All right, then we arrange them from biggest to smallest. All right, so in order to do that, we know that we need to make all the denominators match. We need to have a common denominator. All right, so to find the common denominator, we need to find the least common multiple of all of our denominators. So we're going to use one of the methods that we learned back in Unit 2 to find the least common multiple of our denominators. All right, we're going to use the prime factorization method. All right, so let's start by finding the prime factorization for each of our denominators. For 22, that would get broken up into 11 times 2. Those are both prime, so 22 can be written as 2 times 11. For 13, 13 is prime. It can only be written as 1 times 13. Right, so its prime factorization would be 1 times 13. And then for 16, I broke 16 up into 8 times 2. You could do 4 times 4. That would be fine. And then 2 is prime. I'm going to go ahead and split 8 up into 2 times 4. 2 is prime. I'm going to break 4 down even further into 2 times 2. So there's my prime factors. So I can rewrite 16 as 2 to the 4th. All right, so now that I have the prime factorization of each of my denominators, I can use what I know from Unit 2 to find the least common multiple of those denominators. All right, so I first start by writing out all their prime factorizations. 22 is 2 times 11, 13 is 1 times 13, and then 16 is 2 to the 4th. Now, if you remember, the process for finding the least common multiple is we're going to include all of the factors from each number, and then we're going to raise that to the largest power that occurs in any of the prime factorizations. So our least is going to be 1 times 2 to the 4th times 11 times 13. All right, so 1's in there because it's part of the 13's prime factorization. 2 is in there because it's part of 22's prime factorization and 16's. It's raised to the 4th power because that's the highest power that occurs in any of those prime factorizations for 2. Then multiplying times 11 because that's in 22's prime factorization. Then multiplying by 13 because that is in 13's prime factorization. All right, so if you multiply all those together, that's 2,288. Very large number. All right, so we have to make all of our fractions have the denominator 2288. So what I did here is I just grabbed my calculator and I said, okay, 2288 divided by 22. All right, so I had to multiply by 104 to get to 2288. All right, so I just took my least common multiple and I divided it by that denominator to figure out what do I need to multiply by here to get to that least common multiple. Ideally, if you were doing this with your students, obviously, you would have much smaller numbers and it would be more obvious what you need to multiply by. All right, for 13, I did the same thing. I did 2288 divided by 13. Sorry, I got ahead of myself. All right, so once you multiply 11 times 104, that gives you 1,144 over 2288. All right, now I'm going to do the same thing for 11 over 13. I have to multiply by 176 there. All right, that gives me 1,936 over 2288. Then I'm doing the same thing on 11 over 16. I did 2288 divided by 16 to figure out what I need to multiply by. Right, so I have to multiply by 143. Right, once I do that multiplication, I get 1573 over 2288. Right, now that I have a common denominator, I'm just going to look at the numerators, and that's going to tell me the order that I'm supposed to arrange these in. Now that all my denominators match, I can just focus on the numerators. All right, so I can see that this fraction on the left is the smallest, this fraction right here is the biggest, and then this one goes in the middle. All right, so smallest, biggest, and then the one that's left over goes in the middle. All right, so rearranging those, 11 over 22 is the smallest because that matches up with this fraction, so it goes first. Oh, I'm sorry, I wrote these in the wrong order. No. Yes, I did. Sorry, guys, these are in the wrong order. All right, instead of re-recording this, I'm just going to fix it. All right, so I wrote them in the wrong order. Okay, let's cross this out. Okay, now let's write them in the correct order. Decreasing means the biggest one goes first. All right, so that's going to be, let me change the color. Okay, so biggest goes first, so that's this middle one, so that's 11 over 13. Then the middle one is 11 over 16. Then the smallest one is 11 over 22. Yeah, that's decreasing order. That means the biggest one goes first, then they get smaller each time. All right, so that is just an introduction to rational numbers and gives you an idea of some of the stuff that we're going to be covering in this section. We'll go more in depth talking about some of the concepts that we learned in this video. And if you have any questions, please let me know.